Hey guys, welcome back to another episode in the Python series. In this episode, I'll be teaching you about number data types. Alright, so last episode we learned about variables, how to create variables, how to reassign variables, how to properly name variables, all those cool things so that we can store data, right? But there's different types of data that we can store within a variable. There's numbers, there's strings, there's lists, there's all kinds of cool things because there's different ways to represent data in the real world, right? So the first one I want to teach you about is how to represent numbers and store them in variables, okay? So there's two different types of numbers. There's integers and floats. So floating point numbers. Now an integer is really just a fancy name for a whole number. So if we create a new variable called my age, and I'm currently 20 years old, I can simply put 20. And the 20 is a whole number, but it's also called in computer programming an integer. So anytime you have a whole number, whether it's negative or positive, you can call that an integer. And there's not too much to it otherwise, it's a pretty simple concept. But one thing that is different from other programming languages is that in Python, an integer can be pretty much any size that you need. So let's say that I want to say how much I love tacos. I can put a really big number in here, and that's perfectly valid. And I can print it out. So let's first print out my age, and then let's print out how much I love tacos. So both of these numbers should now be printed out into the output if we run this. So let's go ahead and so currently it's configured with hello world, the file we used previously. So I'm going to right click this and just do run in variables. There we go. So now we get 20, and then we get this really big number, and there's no problem because in Python you can use really big numbers with integers, and there's no problem. So that's really different from a language, for example, Java, which is one of my favorite languages. In Java, you cannot represent an integer with such a big range because integers are represented by usually 4 bytes of memory. So 4 bytes can only be so big or so small. It cannot be this huge, giant, massive number. So there's ways to do that in Java, but generally speaking, for a regular integer data type, you cannot really do that. But the cool thing is that even if you didn't understand what I just said about Java and all that, in Python, you don't have to worry about all that complexity. You can just use numbers as you would want to use them. So this is really cool. And like I said, you can also do negative numbers. So we can do negative that. So if we rerun this, we'll get negative. There we go. So we can create another variable if we wanted to. So negative is equal to negative 999. So print that out, negative, and we get negative 999. There we go. So those are the basics of how to use integers. Again, they're just really whole numbers that you can have as pretty much any size. Now into something even cooler is floats. So floats. So a float is a data type that supports decimal points. So decimal pointed numbers. So essentially any number that you have a decimal inside of, that's a float, okay? So let's say that we want to represent pi. That's a very popular number in math. So 3.14 is the most basic way of representing that. So if we were to print this out, we would get 3.14. Just the reason I'm printing it out is just so you can see that it works, no errors or anything like that. So there we go, 3.14. So floats are also just numbers just like integers, and you can store them in variables as you want. But just know that there is a difference between an integer and a float. One of the big differences for Python is that a float is limited on the size, okay? So let's say that you want to make a really big number and represent it as a float in a variable. So we could have pi, so equals to 3.14. And let's say that, as you know, pi goes on forever. It's like an infinite repeating number. So what we can do is do more precise pi, make a new variable called more precise pi, and we can add more numbers onto the end of that. So let me go ahead and Google what is pi. So here we go, we get pi to the millionth digit, so we have all these numbers here. So let's just go ahead and copy a good chunk of it, and then let's put it into our variable. Copy that, close it, paste it here, and there we go. So now we have a new variable called more precise pi with a value of 3.14159265358979322 384626438382795028841971693999. You get the point. So if we printed this out, let's do pi first. That's no issue. But then if we print this one out, more precise pi, you're going to notice something interesting. So there we go. And this time you can see that it doesn't print the entire thing because, like I said, floats are limited in the size that you can store within a variable. Now there are ways you can get around this using different libraries in Python or other trickery, which we can learn about later if we need to. But just know that a float is limited. But generally speaking, for most of your programs, this is a very, very high precision. So you don't really need something bigger than that. Like that's a really, really, really precise number. Precise meaning that how many digits are after the decimal point, right? So yeah, you won't really need anything much more than that in most of your daily programs. So those are floats, and they can also be negative, of course, if you want to. They don't have to be positive. So print this out. There we go. We get negative floats. So those are integers and those are floats. So variables that store numbers would not be very useful if we could not do math upon them. So you can do math upon them. So let's again, for the third time, have a variable called pi. So if pi is equal to 3.14, let's also have a variable called radius. That's going to be equal to 24, and that'll just be meters. Pretend this is like a physics program or something that you're working on. And then let's have a new variable called area of circle. And so what we want to do is use these two variables, the pi and the radius, to calculate the area of a circle. Now, if you look up what is the formula for the area of a circle, it's just pi times r squared. So we can do that with these here. So we can do pi times and then radius times radius. So I put it within parentheses here because of order of operations. So essentially it's gonna execute radius times radius, so squared. That will give you the radius squared, and then it's going to take that value and do times pi. So you're going to get pi times radius squared, and that should be the area of the circle. Okay, so let's print this out. Area of circle, run this, and we should get that number there. So if you want to double check that, go ahead and pull up a circle area calculator. Throw these numbers in there, or just throw this one in here. It'll already have pi with it. And then you should get a number very close to this number here, okay? You may not get the exact one just because the preciseness of pi that we're using here is only 2 digits, but you get the point, right? Now we're going to have a dedicated video on arithmetic with Python. So I'll be showing you how to do the basic stuff like addition, subtraction, multiplication, division. I'll also show you how to do modulus, which is a way to find the remainder of a division. And then also how to do like squared, so radius. You wouldn't have to do radius times radius. I just wrote it like this because it's simple, easier to understand before I do that episode. And then also I'll show you some more stuff on order of operations. So stay tuned for that. Okay, this is just a very basic example demonstrating that you can do math upon your variables. So essentially we're creating a new variable here and basing it upon the arithmetic done upon these other variables here. Okay, so those are integers and those are floats, the different data types you can use to represent numbers in Python for variables. Now there is a different data type for complex numbers in Python, so you can represent complex numbers and stored in variables if you wanted to, but I'm not going to show that in this video just because it's not really too relevant in everyday programming, and I'll show that in a later video, okay? Now we're almost done, so I'm going to show you two different ways you can represent integers and floats within Python. So currently, if you have a really big number and you want to store that in a variable as an integer, you can do big number is equal to, and let's say we want to represent 21 billion. So we'll do 21 0 0 oops 0 0 0 0 0 0 0 0 0. So that should be 1 billion. And then if we want to print this out, we can verify it's storing 1 billion. There we go. We get 1 billion. But obviously, if this is not even your program, or if you leave this program and come back to it later, you may not know what this number is just by glancing at it. You would have to count the zeros and try to understand. It would take a second, right? Especially for even bigger numbers like 21 trillion, right? So one thing you can do is actually you can add underscores within your integers if you wanted to, or your numbers. So now it's like having commas within the number, so you can see much easier now that it's 21 billion and not something else like 21 million or 21 trillion. It's something you could understand more quickly. So if you print this out, it'll still print out the same thing, but without the underscores. So this is just how it represents to you as the coder, but internally you have the number 21 billion without the underscores, okay? So it's a thing to help you out, essentially. Another thing that helps you out is you can do scientific notation within Python, which is really cool, especially if you are making a program for physics or calculations or stuff like that for math. So let's say that we want to represent the electric constant. So electric constant, this is relevant for physics especially. So the electric constant is going to be equal to 8.85 times 10 to the negative 12. So you could do that. So 8.85, so times 10 to the negative 12. So this should be what that looks like if you were to write it out explicitly. But obviously that's really annoying and really tricky to read. You can't just look at that right away and understand it completely. So we can do it. We can reassign this variable if we want to and represent it in exponential notation. So we can do 8.85 e negative 12. So this is the equivalent of writing 8.85 times 10 to the power of negative 12. So you would get this internally. So if we print these out twice, let's just print it out electric constant here, and then let's put it before we reassign it. So we should hopefully get the same thing twice. And there we go, we do. So it seems that Python actually just converts this right away to the exponential notation, and that's how it outputs it for you. But internally, of course, Python won't have it stored as e, right? It would have it as an actual number. But just for ease of reading, it will do that for you to print it out as e to the negative 12. So there we go. So that's how you can represent floating point numbers in exponential notation in Python. All you have to do is put the e. That represents like the times 10 part, and then the number after it will be the actual exponent itself. So you don't have to do a negative, of course. It can be a positive number. So if you want to do something like yo mama's weight, you can do like 45.67 e 69. So in real life, that would be 45 times 67 times 10 to the 69. Okay, so that's how you can do basic numbers within Python. I showed you the basics of integers and floating point numbers, or floats as they're called. And also, how you can do math upon those variables if you want to, because math is very important in programming. And then finally, the different nuances for how you can represent numbers like integers and floats. So with underscores and exponential notation. So hopefully you enjoyed this, and hopefully it was informative. Alright, so that's it for this video. Thanks for watching. In the description below, I'll leave a link to the code for this episode so you can check it out. You can bookmark it, come back to it later. If you forget any concepts or you just want to review the concepts I taught in this video, I'll mark everything up with comments so you can come back and read the code without having to rewatch the video, although your reviews are greatly appreciated. So yeah, I'll leave a link for that in the description below, so make sure to check it out. And another thing is I'll leave a link to our Discord server. It's a big community for programmers. You can ask for help on your programming projects if you're stuck on something, or maybe you can get some new friends. If you don't have any friends, there's lots of people here. It's growing really fast. You can find lots of people who are passionate about the same things as you. For example, if you like Minecraft Spigot development, you can find lots of people who like that. If you like C++, if you like Java, if you like web development, it's a really, really big programming community. So feel free to join. There's a link for that in the description below. And the last thing I want to tell you is that if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, and you can cancel at any time. You get some cool perks like early access to all of my new videos, a cool rank on my Discord server like you see right here on the side, YouTube members, and also you get to see yourself on the screen like you see right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. And thank you. Thanks a lot. And that's it. So if you like this video, leave a like. If you want to see more, subscribe. And peace.